Coming to the next topic, resistance and factors affecting resistance. As previously we discussed about resistance. What is meant by the resistance? As earlier we discussed, resistance is the property. Resistance is the property of a conductor due to which opposes the flow of current through conductor is called resistance. So those materials have the resistance. Those materials offer the resistance are called as the resistors. Called as resistors. So this resistance depends on some factors. They are length of the conductor, area of cross section of the conductor, nature of the material, temperature of the conductor. So based on these factors, the resistance of a resistor, the resistance of an electric conductor or the resistor depends. So effect of length, how the length of electric conductor affect the resistance of electric conductor. So it has been found that by the experiments increasing the length of a wire, then the resistance also increases, and decreasing the length of the wire, then the resistance decreases. So the resistance of the conductor is directly proportional. The length of the conductor is directly proportional to R is directly proportional to length of electric conductor. If the length is increases, then the resistance of the electric wire or electric conductor also increases. So R is proportional to L. So here L means the length of electric conductor. R means resistance. Since the resistance of wire is directly proportional to the length, therefore, when the wavelength of a wire is doubled, then the resistance also gets doubled. If the length of the conducting is halved, then the resistance of the conductor also halved. So when we double the length of the wire, then the resistance also increases. For example, just assuming that if it is an electric conductor, so there must be a potential difference. So if the length of the conductor is increases like this, if the length of the conductor increases, then the resistance also increases. If length of the conductor is decreases, then it is also decreases. So when we double the length of a wire, then this can be considered to be equivalent to the two resistance joined in the series, and their resultant resistance is the sum of two resistance than the original value. So finally, a simple thing is resistance depends on the length of the wire or length of the electric conductor. A long wire has more resistance, a short wire has a less resistance. So when we join the two wires, then the length of the wire is increases, the resistance also increases. They are connected in series. So resistance become double than the original value. So one of the factor is length of the conductor. So resistance is directly proportional to length of electric wire. Then coming to the second one, area of cross section of the conductor. So area of cross section nothing but simply you can say that diameter. Since so the resistance of conductor is inversely proportional. The resistance of conductor is inversely proportional to 1 by A. So area of cross section. If area of cross section is more, then the resistance is less. If the area of cross section is lesser, then the resistance is more because of inversely proportional. Since the resistance of a wire is inversely proportional to its area of cross section. Therefore, when the area of cross section is double, its resistance gets half. If the area of cross section of wire is half, then its resistance will be get double. So we know that a thick wire has a greater area of cross section, whereas a thin wire has a smaller area of cross section. This means a thick wire has less resistance and a thin wire has a more resistance. So for example, if you take this is an electric wire and this is also an electric wire. So both are connected in a circuit, for example. Both are connected in a circuit like this. So it has more cross section area. It has a less cross section area. So with the more cross section area, its resistance is less because of space is available to move the electrons. So less collision takes place. When the less collision takes place, then the obstructions are less. So when the obstructions of electric movement of electrons in a conductor is we can call as resistance. So due to the less obstruction, so a thick wire has less resistance than a thin wire. So less area, so obstructions are more. So when the obstructions is more in case of electric wire, it has less area of cross section, then less space present to move the electron. Due to the more collision of electrons takes place, then the resistance increases. So finally we can say that a short length of thick wire is used for getting low resistance, and a long thin wire is used for getting a high resistance. Nothing but simply the thickness. You can say that more thickness, less resistance. Less thickness, more resistance. So in this way, so the thickness of a wire is usually represented by its diameter. It can be shown by calculations. The resistance of wire is inversely proportional. The resistance of electric wire or the electric conductor is inversely proportional to area of cross section or the diameter or the So radius in the resistance is indirectly proportional to the area of cross section. So the thickness is nothing but a diameter. So the resistance of the electric wire depends on the thickness. So the resistance of the wire is inversely proportional to the square of its diameter. Inversely proportional to the square of diameter. For example, R is proportional to 1 by d square. Diameter, nothing but diameter square. So if the diameter of a wire is doubled, the diameter of wire is doubled. So resistance R is inversely proportional to 1 by d square, 2d square. Then resistance become 1 by 4. Then the resistance become 1 by 4. Becomes this resistance becomes 1 by 4. Sorry, R is equal to 1 by 4. When the diameter is doubled, so its resistance become 1 by 4th. The diameter of wire is half, then the resistance becomes 4 times. So finally we can say that area of cross section with the resistance of the wire depends on the is inversely proportional to the square of diameter. So when the diameter of the wire is doubled, made into 2 times, its resistance become 1 by 4th. So how? Like this. So R is proportional to 1 by d square. If it is doubled, you can write R proportional to, means d is equal to 2d. D become 2d. Then we can write 2d by whole square. So R proportional to 1 by 4 d square. So in common number, then R is equal to 1 by 4. So the resistance is become 1 by 4. If d is equal to d by 2, we can reduce the diameter. Then the diameter is equal to d by 2. So whenever we can write R is equal to, for example, 1 by d square. So 1 by d by 2 whole square. That is equal to 1 by d by 4. D square by 4. So R is equal to we can write 4 by d square. So it is nothing but we can write R is equal to 4 into 1 by d square in normal condition. If d is equal to 2d, then R become 4 times. Means the resistance increased 4 times. Similarly, your diameter of wire is tripled, then its resistance will be 1 by 9th of its original value. So more cross section area, less resistance, less cross section of area of cross section, more resistance, and the resistance depends on inversely proportional to the square of diameter. If the diameter is increases, then the resistance is decreases. If the diameter of the wire is doubled, then its resistance is reduced to 1 by 4th. The diameter of the wire is reduced 2 times, then its resistance increases 4 times. So in this way. Then effect of nature of the material. So the resistance depends on nature of the material, what kind of material we have to use. Generally, the electrical resistance of the conductor depends on the nature of the material which is made. Some metals have low resistance, whereas others have high resistance. For example, if you take two similar wires have equal lengths and diameters of copper metal, and other one is nichrome alloy. So if you take copper wire, and nichrome alloyed wire, nichrome alloy. So it has some resistance, it also has some resistance, but here copper has the low resistance than nichrome alloy, so we find that resistance of nichrome wire is about 60 times more than the copper wire. This shows that the resistance of the conductor depends on the nature of the material. Even when compared with the metals like copper and silver, silver has low resistance. Silver has low resistance than the copper, than iron, aluminum, and zinc. So I already shared some resistivities of resistivity of various materials also there in my post, and also you observed in your textbook also. Then coming to the next one, effect of temperature or temperature of the material or the conductor depending upon the temperature. Actually, the electric bulb glows when we connect it to the electric circuit because of heating effect of electric current. Because of heating effect of electric current, when electric current is passed through a bulb, so the filament gets heated to the higher temperatures, and the bulb glows. The bulb glows because to glow a bulb, the filament requires some temperature. So it has been found that by experimentally, we can say that the resistance of all pure metals increases on rising its temperature, and decreases lowering its temperature. So pure metals like silver, copper, aluminum, zinc are the pure metals. Their resistance increases when their temperature increases. When the resistance decreases while their temperature is decreasing. But resistance of alloys like manganese, constantan, and nichrome is almost unaffected by temperature. So, if the temperature of the conductor is more, its resistance also more. If the temperature is less, its resistance also less. Nature of the material and resistance also completed. Length of the conductor completed. Cross section area also completed. Then we discuss one of the important one, resistivity. So what we discussed here, the factors which affect the resistance of electric wire or the electric conductor. 4 factors are affect. One is length of the wire or the conductor. If the length of the wire is more, resistance is more. If the length of the wire is less, it is also less. If the length increases 2 times, then resistance also increases 2 times. Then area of cross section. If area of cross section is more, resistance is less. then if area of cross section is more, then resistance is less. If the area of cross section is less, then resistance is more. And also resistance of the conductor or the wire depends on the square of the diameter. Square of the diameter. Inversely the nature of the material. So the conductor is made up of what type of material? Is it completely pure metal or the alloy? Then similarly the temperature of the conductor. So the temperature of the conductor also affect the resistance. So generally the temperature of the electric wire of the conductor increases, its resistance also increases. Then the temperature of the materials decreases, then the resistance also decreases. So resistance increases in the sensor. So flow of electric charges, flow of electric current is reduced. Meaning is reduced. So I already shared some values regarding that one. So thank you so much. So these are the 4 factors which affect the resistance of the material.